In this video, we're going to learn about production possibilities curves. These are our learning targets. We want to be able to sketch and interpret a production possibilities curve, or a production possibilities frontier, as it's sometimes also referred to. In the graph that we do for the production possibilities curve, there are the basic concepts that we learned from the very beginning, like scarcity, trade-off, opportunity cost, efficiency, marginal analysis. They're all represented in the graph, and I'll show you those in just a moment. And then, of course, you want to be able to apply the graph to various situations. So let's take a look at that graph. Here is a sample production possibilities curve for some country, and we have simplified their economy down to two goods, pizzas and robots. On the axes here, we then have the quantities of robots and the quantities of pizza we can produce. So our first concept of scarcity is represented because there is a curve, a line here, that separates all of those quantities of pizzas and robots which we can produce from those which we cannot. Everything that lies on the curve or inside of it are possible. Anything that is outside is impossible, not possible or feasible with the resources that we currently have. So along each axis, robots, 4. 4 is the maximum number of robots we can produce, and that's if we used everything we had to make nothing but robots. And 28 would be the maximum number of pizzas, again, using all of our available resources. So this line, or the location of our frontier or curve, depends on a couple of things. Number one, the quantity of available resources that we've got. Secondly, technology, and finally, any improvements in those resources or technology that we might see. So if we add more labor because of immigrants, or we get new and better technology, or if we invest more heavily in capital resources like machinery and robots, that could actually change where our frontier is located. Economic growth is usually shown by shifting this whole frontier out further away from the origin, out to the right, because now we've got an expanded range of quantities that we can produce. So once again, the first idea is that scarcity is represented because the graph separates those quantities of robots and pizza which are not possible for us to produce from those which are possible. Now, when it comes to efficiency, all of the points A, B, C, D, and E are efficient. Any point that lies along this curve itself is efficient because it is using all of the available resources and technology. We can't make any more than that. So you've got everything in terms of resources and technology being used. You're fully efficient. A point like F is not possible, so the question of efficiency doesn't even come up. And a point like G is possible, but it's not efficient because we can produce more robots, we can produce more pizzas, we can produce more of both without giving anything else up. That means we must have had resources that were not being used. And again, like a historical example for the United States is, during the Great Depression, when we had a third of the labor force unemployed, we obviously could have been making things, right? Those people could have been producing goods and services, but they weren't. So even though what they did produce was possible, it wasn't efficient because we weren't using all resources and technology to their fullest. All right, so as far as, the idea of trade-off goes, what we find is that when we're on the frontier, the only way that we can get robots is that we're going to have to give up pizzas. And if we want pizzas, we're going to have to give up robots. So those are the trade-offs, right? It's what we give up in terms of the other good, and therein lies also the opportunity cost, because it's going to be the quantity of the other good that we give up that is a measure of it. Now what I've done is I've gone ahead and just shown how that trade-off ends up being measured in terms of our sacrifice of the other good, also known as opportunity cost. So let's say that the country originally started at point A, where it was producing 28 pizzas and 0 robots, and now we decide we want a robot. Well, at 1 robot, if we go up to the curve, we see that we can no longer get 28 pizzas. Now we can only get 26. So 28 minus 26, 2 pizzas. The opportunity cost of that first unit of robots is 2 pizzas. By the way, this is also marginal analysis, right? What is the additional benefit or cost of 1 more? So what is the cost of that first unit of robots? It's exactly 2 pizzas. When I go to look at the opportunity cost of the second robot, in marginal analysis, I'm looking at only what is the additional sacrifice. I already gave up 2 pizzas to get my first robot. What do I have to give up on top of those 2 pizzas in order to get a second robot? The answer is 4, because at 1 robot I could make 26 pizzas. Now at 2 robots I can only make 22. 26 minus 22, 4 pizzas. We keep on going, right? If we want a third robot, now the most we can get is 12 pizzas, because we had been at 22 pizzas. 22 minus the 12, the sacrifice for the third robot is 10 pizzas. And then finally, if we want to make nothing but robots, then we can't have any pizza at all. So we go from having 12 pizzas with our 3 robots to now we only have 0 robots with those 0 pizzas with our 4 robots. So the 12 minus 0, the size of our opportunity cost, the sacrifice to get that 4th robot was 12 pizzas. So that's how the incremental change, the marginal analysis, and the value, the number of pizzas we give up is opportunity cost. We're trading off the pizzas for the robots. So that's where the trade-off and opportunity cost come in, along with marginal analysis, along with scarcity that forced the choices because we didn't have enough resources to have as many robots and pizzas as we might like. We had to make a choice. That idea of efficiency, we're producing using all of those available resources and technology, then we're going to be on the frontier. If we're not using them all, then we're inside. It's possible, but not efficient. Outside, it's not even possible. We can't produce that quantity represented at point F. One other quick thing to point out, the shape of this curve. Notice that from the point of view of the origin, it is concave, right? It looks like a cave I can walk into if I was standing here at the origin. So it's concave to the origin. It bows out. That is the typical appearance for a production possibilities curve. That shape is important. That concave shape, the bowed out version, that represents the law of increasing opportunity cost. So I've just added it over here on the screen. Okay, so if you see or hear a question about why is this production possibility curve bowed out, it's because of the law of increasing opportunity cost. Why, might you say, do the opportunity costs increase? We saw that they did. The first robot required 2 pizzas, the second 4, the third 10, the fourth 12. The opportunity cost got bigger as we forced more of our resources to produce robots. By the way, we usually work this direction, but it's bowed out in both directions. If we were to calculate how many robots we give up to get successive units of pizzas, it would also increase, right? So the opportunity cost increases for both goods. When the curve is bowed out, it means that opportunity costs increase if we force resources to make pizza, or when we force them to make robots, in either direction. The further we go, the bigger the sacrifice becomes. Why? Very simply, resources are not equally suited to all uses. And I think you can understand or realize this, right? Some of the things that are used to make robots are not going to be very good at producing pizzas, and some of the things used to make pizzas are not going to be very good at making robots. So when you're forcing more and more of the resources in one direction, you're starting to force those things that are really good at making robots to make pizzas. That means you give up a lot of robots to get that next unit of pizza. And the same thing happened here as we forced more resources to make robots. Initially, we used things that didn't require us to give up much pizzas, but as we forced some of those really good resources to make robots rather than pizzas, it meant that we gave up lots of pizzas to get those last incremental improvements in the number of robots.